Hello, guys. Hello, attention. Yeah. So, welcome to the third workshop come intro session of Techmaniacs, where we introduce our interest groups and also we teach you some basics regarding that interest group. So, I will give a very short introduction to Techmaniacs. So, Techmaniacs is the robotics and electronics club of IIT Tirupati. Uh, so like what we do, so we take part in competitions, we make different projects. If any student wants to learn something, for that they require any components and all, we can provide it. So these are the various things we do. The projects which we do will be open for all, so if anyone wants to join it, they can freely join it and learn the skills. Also, we provide a platform for all the students to collaborate, so they can work with the veterans in that field, and they can gain a hell lot of skills through hands-on experience. So, as I said, we help students in developing technical skills regarding robotics and electronics. So, yeah, our mission is to induce a technical culture in our institute and boost innovation. So this is the chart, organizational chart of Techmaniacs. Like I am the co-coordinator, Chirag Kotian. I forgot to introduce myself. Okay. So then there are four interest groups: Arduino interest group, electronics interest group, robotics interest group, and drones interest group. So this workshop is for drones interest group. So then we have a head of drone interest group, Rohit, and under him there are a few co-coordinators who has some task assigned to them. Also, under this is our core team. So there are members in Techmaniacs. Member is anyone who does projects or issues components from Techmaniacs. So if you are interested, you can be a member. There is no restriction in that. Yeah. So as I said, there are four interest groups, and there is one asterisk, as you can see, in 3D printing, because earlier 3D printing was a separate interest group, but we thought 3D printing has become such an important skill nowadays that everyone should learn it. It would be very helpful for making projects, prototyping, anything. So, so these are our co-coordinators, and also you can see their roles. So if you have any, like if you want to issue components, and you want to do a project under certain domain, so you can contact the respective person. If you have some new project and you want to initiate it, you can contact me or interest group head. Also, we are trying to make a document repository of documentation of projects. So in future, if anyone wants to make start new in this field, or someone wants to work upon a project which has been done in the past but do some advancements, they can refer to that documentation. We soon will be releasing our link to our GitHub repository. There you can find few projects. It's small now because we started it this year, but slowly and gradually, as years pass on, our repository size would increase. Yeah, so how you can be a part of the club? So this year's core team member selection is done. So no worries, but you can join us as a member. So the benefit of being a member is you will learn, as I said, you will learn from people who have experience in that field. Not only that, you all guys know that in this December month there is inter IIT competition between IITs. So if you are a good participant in our club, you work hard. Like the interest group head is pretty impressed with you, so he can recommend your names to the selection committee, and selection committee can directly select you for problem statements related to inter IITs. So this year's inter IIT is very hard. It has been promised by IIT Madras that it would be very hardware oriented. So being a part of our club will be very helpful in that sense. Uh, yeah. So this was short introduction to Techmaniacs Club. So if you have any questions or something, you can shoot me an email. You can also WhatsApp me on the number. So to continue with the workshop, I call upon Rohit, the interest group head.
So, okay, check. To begin this meeting, I have just three questions to ask you guys. So, before I start, how many of you guys have flown a drone before? Just A show of hands. One, two, three, four, five. Okay. Okay. So the ones who have flown drones, like what type of drone have you flown before? Like like first person view or what kind? Okay. So to the ones who haven't flown a drone before, what kind of like what piques your interest about drones? Like what would you want to do about if you had a drone and you could make any drone you wished? What would you do with it? What piques your interest about drones? Like, I'm not interested. I see. Okay, I'll hand it over to Tanvi. She will start the presentation. Introduction to drones from Techmaniacs.
So, hello everyone. Today we are welcome to the Drone and Aeronautics Club orientation, and here we are going to small glimpse of the world of flight and aeronautics and all that. First of all, I wanted to know that what do you mean by the term drone? Anybody?
Just some guesses. What we call in short term. Short form. That the name you described. So a drone is flying.
So basically, a drone is a flying vehicle that is operated without anyone present inside it. So it can fly remotely and also by itself autonomously. That makes it very beneficial for multiple operations as we don't have to go through the hassle of training a pilot and all those things. So now we are moving on. So basically, we have structured our project into four fields of drone technology. They are building and manufacture of drones, mastering flight of drones, creating firmware and algorithms for autonomous flight, creating UAVs, fixed wing drone projects. So first of all, in building and manufacturing of drones, what we are doing, that is crafting the optimal drone's shape according to the laws of aerodynamics and laws of physics. The second is the mastering flight of drones. Means the putting all the requires flight requires precision and lots of training, and all those things come under mastering flight of drones. Creating firmware and algorithms for autonomous flight is creating the firmwares and algorithm. Basically, it is related to the computer engineering students. And the fourth one is the creating UAVs, fixed wing drone projects. So till now, who didn't join the WhatsApp group, please join it for the updates and all the next projects. Basically, in that, if you guys don't have any experience, just join it. You will have some experience after joining it. And if you guys have some experience in 3D modeling, aerodynamics, communication and control systems, computer vision, navigation system, and GPS, expertise in manual flight. So if you guys have any experience in this, you will able to help in the projects of drones. So first of all, our mission is to create so many projects, 4 to 5 projects in the for IIT Tirupati, and to reach some local companies and startups to work upon the projects. First of all, we will means try to reach to the inter IIT projects and all that to make innovations in the field of avionics and aerospace. So Some of the projects are disaster response. Disaster response is like we will going to see what the problem is there, and the drone is able to run in those hassle conditions and all that to see the victims and even to deliver some aids to them. The second one is data collection. Data collection is like wildlife areas, collecting the data about the wildlife areas and all. The third one is flight avionics, communication relays, automatic flight, and communication systems.
So when we make projects, we get inspired by a lot of our peers. Newton said like he only got that far because he only stood on the shoulders of giants before him. So like we are also inspired by a lot of projects by foreign universities, other bigger institutes and things like that. I just wanted to share the video of a drone by ETH Zurich with you that interested me a lot. I hope you can also get inspired by it. Okay, so this kind of project like it takes interdisciplinary knowledge. So it takes knowledge of computer engineering, it takes knowledge of inverse kinematics, it takes knowledge of electronics like control of servos, it takes knowledge of computer architecture. You need to define your computer in such a way that it can perform these computations in such a fast speed that it can react while flying. Uh, this was made by master students of ETH Zurich. It's like it's a university. It's the biggest university in Switzerland. So we don't hope to make something like this, but we hope to get inspired by the general principles, the ideas they use, and things like that in our future projects. Okay, yeah. So you can see the video. That is that is me. That is. Acha, okay. That, that is me. That is Prakhar. We made a quadcopter in the second semester. Same thing. It's a similar concept. So So there are many types of drones we can make. The most common ones are multi-rotor drones, single-rotor drones, flex-wing drones, fixed-wing drones, and UAVs. So they have different uses depending on what your use case is. So the multi-rotor drones, they are very basic to make. They can fly in many circumstances. The single-rotor drones, they conserve battery and fuel a lot. They conserve battery and fuel a lot. Of the multi-rotor drones, the quadcopter is the most common type. Like when you think of drones, the first thing you think of is the quadcopter itself. Like because it can be modified and made to work under many circumstances. There's also hexa and octocopter drones. They are a lot bigger and can lift a lot of weight. Hexa and octocopter drones. Other than that, there's also tricopter drones, bicopter drones. They are small. They can be like very nimble, very agile. Single rotor drones. They can conserve a lot of battery. They can be made to fly with an engine. That's why they used it for military purposes also. Now, flexible wing drones. They are a really interesting project. Flexible wing drones are usually they're made by research projects. So I'll just show you a video to explain how it works. So you might have seen Uri the movie. The drone in Uri the movie, that was a flexible wing drone. They can be made to fly among birds because birds aren't distracted by them and they can be camouflaged very well. Fixed wing drones, they're like basically a plane. So it's drones. When you think of drones, you normally think there's a spinning propeller, but fixed wing drones they function basically like planes. Uh, so there's the one propeller in the back, and the rest is driven by the wings itself. The lift force is generated by the architecture of the wings. Yeah, yeah. I guess we will show you the videos later because the Wi-Fi really isn't collaborating with us. So there are many uses of drones. Search and rescue drones. We plan to make a search and rescue drone in this year itself. So this is one of the examples of search and rescue drones. They can be used to transport lifeboats to anyone who's stranded at sea. They can be made to work in under like floods. There can be many purposes of search and rescue drones. This is not the only one. They can be made to locate victims. They can be made to provide like medical aid to victims, packages like that. This one is a bit dystopian, but in the future, you might see police use drones. I think they already use drones in many like high risk areas to monitor areas where crime might potentially be happening, where we don't want to assign a police unit to it. Traffic monitoring drones, they're still a very nascent idea. They're very new. So basically, you can see here, it's a drone flying in the sky. It's tracking like which vehicle, what speed they're at. Like if anyone breaks the rules, it falls basically into a surveillance drone kind of thing. Yeah, one of the other uses is actually NASA has made this drone. This drone is a repurposed military UAV. It's been repurposed by NASA. So in the USA, every year there's a hurricane hitting. So NASA uses it to live track the hurricane. It can fly within the hurricane itself. So it has like a body that's rigid and strong, built to fly in a hurricane itself. It can provide live real time data tracking of what affected areas are. It can provide better research on what things like the kind of damage the hurricane is doing. So the next in the Russia-Ukraine war that's happening right now, drones are playing one of the biggest parts in achieving air superiority without using a big military jet plane because those are very expensive, right? But drones, we can use drones to take space in air control. Now I can't show you a picture of war because that's not ethical. Like we can't show you a picture of war during a Techmaniacs meeting. So I'll show you like some Call of Duty footage. Okay. Yeah, we will skip the videos. I'll show. Yeah, we'll share you the videos later on. But I think a lot of you play Call of Duty already. Yeah, there's a UAV drone in the Call of Duty, right? Yeah. Yeah. So firefighting. This one is again a video. I'll probably not play it, but They made it to autonomously detect fires, and like, so it's powered by a pipe. So it's powered by the fire hose. The thrust isn't generated by the motors. The motors are only there to provide direction to the pipe. The thrust is provided by the opposite reaction provided by the force of the pipe, the water thrusting through it. So it's connected to a fire truck. It can automatically fly to the highest story and fight fires from the top down. Like currently, we have to supply firefighters from the bottom up, which can take a lot of delay in saving the people who are high up in the upper stories of a multi-story fire. If the fire breaks out in a multi-story building, so drones can help people who are in the upper floors as well. Now the next video is, how many of you have seen the freshers introduction video? Yeah, you must have recalled this shot. This was taken by the PFC Photography Club. They have a DJI drone. Sawmill is part of that PFC club. Yeah, they have a DJI photography and videography drone built specifically for this purpose. They take many shots. They take many shots of our campus like this. Even during Tutsava, they have a drone that specifically records like many performances, things like that. Next is personal use. Like actually, a drone is just a big. It's a flying object, right? We can make it do anything. So here's a personal use of drones. We can. Now I'll tell Rohit to tell you about the components of drones and how to technically make them.
So you have seen many type of drones here. Can you tell me how many type of drones have you seen till now? Summarize. Hello, audible? Okay. So how many types of drone have you seen right now? Okay. Can you name some of them? No, UAV is just a completed drone. Okay. UAV is a category. Flex wing, then fixed wing drone, then quadcopter. In which category it falls? Single rotor. Okay. So first of all, the most common is multi-rotors. Multi-rotors, which we are using more than two or more than two motors. Okay. Next, flexible wing, where we have a particular membrane which creates a lift force. Lift force, how many of you know? Okay. Then we have a fixed wing drone, in which if I for each and every drone, we need different components, different specification of everything. So how will we select these time, whatever the components we are needed, how will select them? So I'll just give you the overview of that. So let's just start. Okay, this is a frame. So can you tell me what is the use of frame? Okay, skip this. Out of your language, like from your language. Here. Okay, so structural, like what is the most advanced machine have you ever seen? Advanced machine, more advanced. Okay, it's created by nature. Let me give a hint. It's created by God. Okay, humans, yeah. So how your body stands, it just need a structural support, right? So all your body parts are attached, like you have a particular structural supports. So frame just provides a structure to a whatever the components we are attaching in a drone. Motors, then propellers, and I'll just add more later on. So each and every component will be added to this, what do we call this, frame, sorry. So for the frame, there are many different types of materials. Can you name the most strongest and lightest one? Yeah, good. So right now that we don't use carbon fiber, this is a plastic, glass fiber. Okay, carbon fiber is out of budget, I guess. So is frame clear? Okay. Okay. So this is a motor. Generally, we use brushless DC motors. BLDC stands for brushless DC motors. We do have DC motors. Can anyone tell me what is the difference between both of them? Hmm? Okay. Any other? Okay. So the whatever components I am showing you, my teammates will share with you. Okay. They will distribute among you, and you have to watch them. We'll ask question according to that. Last five. Is it boring? How many are feeling it boring? Boring one. Now you can be honest. Okay. First, just share them this frame only. So, okay. I'll describe you. Don't try to get there. पहले फ्रेम फ्रेम दे दो. जल्दी कर दो थोड़ा. Frame. Okay. So, how many of you got your hands on frame? You got? Ravish? Frame. Just hands on. Okay. और base plates भी थी ना? PCB plates. Okay. The material you are having in your hands for the this we call as the hand of a drone. Okay. So as we in human body, am I audible to all? Do I need mic? Okay. So as we have like legs and hands, right? Drone also have a legs and hands, and we can increase as we seen in multi-rotor. It can go up to 8 hands. Okay. So next thing is propeller. Anybody has that, guys? How many of you have got propellers? Okay. ज़्यादा जल्दी लविश कर दे. हाँ दे 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 वापस दे दे. It's your duty to submit it back. With a single part, you can't make anything, I guess. Divyam, you guys come in front. Okay, we are not assembling it right now. You have to come to me or if you have to contact us. We'll make something new. This is the old one. Maybe I will be giving you a guide. Like I'll describe it. Okay. Hello. So can we start again? You just share among yourself. So okay. First we saw a frame, right? It's similar to which you have in your hands, right? So this is a glass fiber, which is enough strong. Okay. So have you got the upper plate? This black with golden tilt. Okay. So and the lower plate. This is a lower one is called as a PCB plate, which has a circuit, inbuilt circuit. Uh, can I get your attention? Okay. So this is a circuit. We attach a battery directly to it lower plate. You can see some um, lead tin alloy, some kind of thing. Okay. So next thing we do have motors. Motors. How many of it? Like how many you got the motors? Okay. So usually we use BLDC motor, which is called as brushless DC motors. The reason is they have high speed, where they have low torque. Like torque is enough for propelling, but in compared to DC motor, where the stator is inside the motor, like this is the outer part is rotating in this motor. Okay. Next thing is propeller. Again, what the issue? Huh? नहीं मैं कर दूंगा पर यहाँ से नहीं हो रहा है. आ रहा था दोबारा क्या? Okay. So 1000 is, can I get 1000? What I said, 1000 is RPM per volt. So what if I give a voltage of 11.1 or 11 volt? What will the RPM? Okay, so that's 11,000, right? Next, it's written as 13T. 13T. 13 is 13 turns per pole. Pole. So pole is, this is the pole, right? There will be 13 turns in this. Okay. The number you increase, the more torque you get, but you will, at what cost you will, like with the speed. Okay. So propeller, motor, clear. Next we come to ESC. We can't give 11 point volt every time. We have to decrease or increase by the time, because there will be deflection. Without deflection we can't flow. So 11 point volt is the maximum. Like a battery we have a of a 11 point volt, so it can charge up to 12.6. Like each cell has a 3.7 volt minimal volt, and that will charge up to 4.2 volt. Three cell we usually use. So with ESC what we do is, this is connected to a brain, which I'll be describing in a moment. This will give a voltage based on our transmission signal what we are giving. Clear? So this is ESC, short form ESC, and the full form is electronic speed controller. Okay, so as human mind, all of you have a brain. You order your hands, legs with your command, whatever you. So this is a brain for a drone. This is a basic drone. We have a like basic flight controller, but we have upgradation to this also. Like this is a learning phase. In this, there are some sensors: accelerometer, barometer, magnetometer, and gyroscope. So can you tell me like a function of anyone? Orientation in what aspects? Okay. Can anyone tell me of barometer? Okay. Then we have multi like accelerometer. Okay. Oh, so these all of the things are embedded in one thing, which is called as IMU. This is a chip, the upper one. Okay. Some electrical signals and reflection, whatever things, it will calculate that, and we do have a processor. That processor will transfer details to ESC. I'll show the circuit diagram later. This is a flight controller. As of now, take it. Okay. So should I need to describe it or it's clear? Okay. Here, for this KK controller, this is called as KK2 1.5. The name for this flight controller. The front side is decided by the IMU chipset. Upper side, the lower side, back side is this button. Okay. So here there are pins you can see. In ESC, there are pins. Okay. Exactly. So in this, we do have three pins. Like first one is for ground, second one, red one is for this positive 5 volts or different volts, and the third yellow one is for signal. So how we connect them? Okay, I was thinking you should guess, but the inner side is usually a signal pin. It can vary in different flight controllers. Okay, so in this flight controller we can connect up to 8 motors, which can be a servo motor and be a DC motor, depends on your requirement what you are making. This 4 buttons are for configuration of this display. Clear? Then the other side. Okay, so our drone is flying in the air and we are giving a constant velocity, like lift force. It's flying. How will you make it to get lower, upper, sideways, and whatever the orientation? Okay. So here we connect a receiver, which is connected wirelessly to the transmitter. Okay. So till now everything should be clear, I guess. Is there any doubt? If any, you can ask me. Okay. Okay. So as I talked about this transmitter and receiver. You are connected wirelessly to the drone. The wheel transmit data. I can show you the controllers if you wanna see. Just give the okay. Don't play with the triggers and all. टूटा हुआ है वो निकल गया ध्यान से निकाल हम्म? नहीं दे रहे कुछ कोई ना ओके सो दिस इज अ ट्रांसमीटर एनी डाउट okay so let's come here again so this is a transmitter you are transmitting your according to your way how you are flying the drone so the transmitted data how will transfer with that like how we gonna transfer that data to that so we do have a receiver for that which is connected at the place of the 5 pins okay the left side pin yeah here again we have positive negative and this signal pin okay I'll tell you the orientation in the next slide okay transmitter receiver clear okay here transmitter and receiver clear if no you can raise your hand okay so for powering drone we definitely need something we can't directly add electrical like our motor is electrical okay so we usually use lithium polymer battery because of its low weight and high efficiency right we do have another specification lithium metal one nickel cadmium lithium polymer lithium ion also here we are using well so most probably we will be using lithium polymer in most of the cases so what is the primary function of battery can anyone guess okay how it works no okay okay so let me so battery turns chemical energy into electrical okay then electrical energy will be converted to yeah so that goes to up to motor this is a camera it's depending on our optional if you want to add probably we add but it's our according to us so this is a circuit the flight controller I show is a basic one the flight controller we are using is a pixel which is an advanced form here you can upgrade yourself upgrade your drone autonomously you can fly you don't need to fly like with your hands like with remote you can it will fly you have to give just coordinates it will follow that path so I'll try to explain with that so this is flight controller as I told you brain connected to this we have four motors this probably is a quadcopter okay these four motors like Pixoc is another here this is called receiver then that is Raspberry Pi the have you seen that not Raspberry Pi is again a computer microcomputer you can say so you in the earlier video you saw that shape changing drone so how was it working it's on this you program it according to this it's again a company adding a more brain to it next we have telemetry kit again controller kind of thing that's a controller if you need some time override it you can do it otherwise this is a telemetry you can monitor your drone if it is a high precise it is if you are it is out of your reach out of sight so you have to use telemetry it will give a proper specification of your drone how it is flying at what altitude at what range how you should operate it. Otherwise, if you fail the connection, if connection fails, how it works, everything you can control with telemetry. GPS, compass, I guess I don't need to describe it. Okay, so is the term PPM encoder. Can anyone? Mm, okay, PP. What does PP mean? Okay. Any idea about PWM? With modulation. This is pulse position modulation. That's the same, similar to modulation. That's it. So almost same. It's just a type of transmitting data and positioning. They've all. It's again a pulse. That's it. It's clear circuit because I'm not going to tell you again. If you come to me, I will start with the projects. Okay. So how quadcopter flies? Like we took an example of quadcopter, right? Throttle. Okay. Thrust. Okay. Throttle is you are giving constant velocity to each motor. Then same like we have pitch, roll, and yaw. Let's just fix some coordinates. This is z-axis. We take it as a y-axis, you and me. This one is your x-axis. So throttle, if we are giving a same speed. Okay, same speed. Okay, so it will throttle up with the lift force we are using. If the weight of drone is like lift is less than the drone weight, how will it react? Okay, if it is equal and if it is more, okay. So there's a lift is clear, right? I'll talk about the thrust also. Pitch, front and backward. You and me. That's going to be direction. That's your axis. You're clear. Anybody else? You're clear. Then we do have a roll. Yes. Okay. Let me show you something similar to that. If you are not clear. Okay. So why are we using counterclockwise, like two different direction of motor? Pardon? In what aspects? Why you are balancing it? Okay, so let's call moment. 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 If you give a single direction, the reaction force will turn it another direction. But I was asking that. Okay. The things I have explained is a similar thing. I did a video. If you get confused, you can ask me. So let me show you live one, if possible. For now, I am giving a equal constant velocity to each and every motor. Right now, we have quadcopter, but okay. So here we are not using a BLDC motor. We are using just a DC motor with micro motors. We usually say dimension 720, 7 mm 20. Okay. So propulsion, everything is clear from that. I'm just elaborating this. So we fixed up some coordinates. I'll fly according to that. Okay. So I just took off with a equal constant velocity in all propellers. Your axis and my axis. This is pitch. Okay. Now this is roll. Clear? Left one is we are left with, and one more term is there. Okay. So your is this. So this is drone which is probably developed by IIT Bombay. In this, we can encode it in our specification. Is that clear? We'll try this on. Don't worry. So these were the some things which are essential before you begin in drones. If you are not clear, you can ask me right now. I'm going to provide how to select components for each and everything, a guide for that. If you are interested, go through it. We'll start with, I'll show you some projects. You have to choose your domain and you have to come according to that. Probably we'll be taking some, that's, you think you can think as a problem. So I think there is no questions. So can we have a quiz? Yes. Sure, Tanvi. You can ask me if there any doubt. Uh, it's up to you because okay. How many you are aware about Mentimeter? Okay, so just share the site. Open that. Close. Karu? Okay, so let's get back on track. So this is projects for this year. First, we'll be starting with a fixed wing drone. Any idea? What can be fixed wing drone? Uh, don't go on the picture. Fixed wing. No? Fixed wing drone. Okay. So let me just tell you about that drag, lift, and roll. First of all, then we'll be able to understand. So this is probably our drone, right? This was lift force. Clear? Okay. Is this clear? Okay. So the upper force we are giving to lift, like the flew. So this is called lift force. Can you guess this one? Lower force. mg, weight w. Okay. So this and this. We do have two more forces. One is thrust, and other can be. Pardon? Which one can? I'm not audible. Air resistance. Can you define that term? The small word is there. Hmm? Some I'm getting here. Like, yeah, correct. This is a drag force, and that one is thrust force. So, how many are fans of cars? I'm coming on line first of all. Okay. So we do have a spoiler in that. Why do we have that? Okay. So okay, this is some Lamborghini, I guess. This is our spoiler. So if we are moving a car in forward direction, the force with which car is conducting the speed, this is thrust one. But the force coming in backward direction, which can be lower side and upper side. Spoiler, the use of spoiler is the airflow will come in this way, right? It will try to keep our car on the ground because the force will maintain. We don't have spoilers and some kind of things in planes. So I hope you got the idea of thrust and drag, lift and weight. If you have doubt, you can ask me. So this one, forward direction we are giving is a thrust. The force which is John cutted already, which passed away, that is that force. So this plane, how it works, usually let's come to a normal plane. They flow in a way where the low pressure here is below the airfoil. Airfoil, wing, which have a particular specification with the coordinates. The So we have to decide for the fixed wing drone that airfoil. We have to decide amount of payload. Payload, any idea? Okay. What weight? Okay. After completing, no. Extra one. After completing the extra one, you are adding that is a payload. So calculating the original weight, then calculating the payload amount, then we have to like we have added the things like we decided we will work on this. We'll add these kind of things. Then we'll decide our specification for that wing. In this case, this total weight was going 1.7 kg. Okay, so this motor has a capability generating thrust of 800 grams with this particular propeller, and this motor is running at 1000 rpm a kV constant velocity. If we decrease the speed or like size of propeller, what should be the specification of motor? Can you guess the higher rpm or lower rpm? More rpm. So for generating the same thrust lift force, sorry, then we do have a if we have a lower kV. Why do have lower kV? Why we are taking the lower kV? Pardon? No. So lower kV, the more tons, the more torque. The size, center of mass you are increasing for the propeller. You need more power to rotate it. You will get the same thrust at bigger size if you are having lower speed. But if you have a smaller propeller, if you are running at 1000 kV, you will not get that enough thrust enough. Okay. So here, how will we making it? Either we'll be making as a VTOL, term vertical takeoff and landing. So in this case, we are trying to maintain our lift somehow ascending, descending. Okay. In this case, we will be adding drag and thrust also. Thrust we do have in this also, but drag is not that much. Drag will be lower, controlling your weight, like letting your plane holding in air. So this going to be a little bit tricky. Even we have to work on that. If you are interested, you can come. Uh, we'll start probably by next week. No sure. I'll order the things. With the next week, we can start. Next, we have. Is that clear, Pixley? Okay. Drone show. We do have multiple events in our campus. How we can represent ourselves? Like we have some things, technical things. Any idea? Any ideas? How can you represent? How can you represent your drone in such a way that it feels attractive to everyone? Banner. You are talking about banners. Banner, some banner written was. That's again a good idea. But again, the specification we have to recalculate and everything we have to add. So this is a drone show. We'll be having some team for that In this, that the smoke one is already decided. The banner one is already decided. So you can't directly rely on that autopilot. So you will be pilots also. Not of now, but later stage. This one clear? This earlier one? Racing drone. Have you seen that? Okay. From the side, have you seen racing drone? Okay. So if you have observed in it, we don't have this much size of propeller. This much size we don't have, and we don't have particular directions of that. This racing drone, it's a freestyle drone. It can move. Doesn't matter, orientation doesn't matter for how many, like for not for the first year, how many have attended KTM one, KTM show. So there you drone with neon green propellers. Okay. That was a racing drone. uh, it has higher speed. It can go up to 250 300 kilometers, depends on our motor specification. Motors can go up to 6000 rpm, which is at 22 volt, 22.2 volts, double the battery. For the battery specification, how we choose is usually most common thing is cells, right? So each cell has a value of 3.7 volt. If we add in series, we are adding three batteries of same volt, same specification. What will the outcome of that? Three times of volt. That is 3.7 into 3 into 6. 22.2. 11.1 you are saying double it. Clear? So guess the speed 6000 to 22. I'm not asking you numbers. It's okay. So here speed matters. Speed of propellers, speed of your vitals also, because the controlling is a bit tricky one. We'll be considering this project at the last one because this is not the essential one. This is my personal kind of, you can say, but we'll enjoy these if you are coming to me. Next we have service drone for disaster response. Anyone guess what can it be? You have seen? No, it's a image. That's the okay. You have seen in previous slides. They can show your drone can be used as disaster. So a question to you: what is the basic rule of upgrading anything? Any more points? Okay, for upgrading, okay, these drones are already available in market. People are using, like already the authorities are using. So it doesn't like there's a no meaning of making a same thing. So upgrading means we have to reach that point. It can be long term also. It can take up to 2 years or more of them. You have to handle later on. So this is a drone which needs better payload, better material type, better propellers, everything it should be better, and it should work in the harsh condition also. Situation can be anything. You've seen that ship changer one. It was going in a cave, right? So here, what can be the thing? Like we can use the telemetry. Telemetry, I told you, you don't need to control with the remote. You can control it with your laptop or something kind of device. So it's clear. Okay. So drone for non-invention wildlife tracking. Okay, we do have to track wildlife, but in this case, they are tracking us, I guess. Probably they are tracking us. So why do we need wildlife tracking one? Okay, already they are using straps which detects something, but at times that connection is being lost sometimes. Drone can work in this because we can get range up to kilometers. We can't decide the range because higher the we go, higher specification, higher range we will. So for this one and previous one, we need a better range. How can we multiply the range? Right now, we do have controllers of 515, like 500 meter. Then we do have 2 kilometers at max. This time we'll upgrade more. So how can we multiply? Okay, we can use a higher uh, range. More ways. Can anyone guess? Two factors. Question is, how can you multiply the range? How can you extend the range, not the multiply? Okay, so intensity has some negative outcomes also. The 5G are using, there is some disadvantage also. Like that there was a test which so many birds died, I guess, if you are aware of that. So probably we'll work on this. First of all, we'll create a range in our campus up to 7 to 10 kilometers. For that, we can directly get a controller. But getting upgrading more, we do have animals in backside hilly regions, which no one is aware about that. No, you can't use like you will fly one drone then another drone. You are using checkpoints. Come on to land. You have one drone. Other things you are placing on the ground. Basically, extender. Same like our Wi-Fi, which works like this. Not it shouldn't work like this. Okay. So these are the 5 projects. We'll add something more. This too can be over ambitious also. With the time, you have to work according to that. Quiz ready? Okay. So can we get to quiz? Till now, any questions? A bit doubt, you can ask me. For Inter IIT, we have will be this drone is going to be in high prep. Chirag bro, Chirag. So drone is in high prep. Okay. So it's not only drones, it's aeronautics also. Aeronautics, I told you fixed wing drone. It's same kind of similar things. So you will be getting like they will release a problem statement by third week probably. For that you should have enough knowledge. Okay, it doesn't matter you don't have practical because where their numbers are very less in our campus with the practical knowledge. You should come to that side also, practical also. Don't be bookie person. So clear? Shall we start quiz? Okay, we have changed the question. One. Again we have 10 questions. Okay, start. Okay, the videos you missed, I'll share on the drone interest group. Okay, so who's our like how many of you are? How many of you are available right now? Just hit the QR code, like the QR code. The QR code I sent on the group now, interest group. Hit it. React to it. Oh, same similar thing. Okay, any suggestion from your side? How we should work if you are not compatible the way we are working?
Rohit.
मैं सोच रही थी केवल 2 मिनट वाला रख लो जो अपन ने उस टाइम पे ट्राई किया था.
जस्ट इन केस थोड़ी कि तुम्हारे ऊपर आ जाए तो सामने के लिए. So we made it autopilot. It will follow some path we decided earlier. This flight is completely automatic. We have set the path on Google Maps. It is automatically flying the path.
इधर लैंडिंग करने थे खुद से. अच्छा लॉइटर पे हो जाएगा.
नहीं लॉइटर पे ले लूँगा मैं.
अच्छा
तूने पोस्ट डाला है लैंडिंग करने से
कर रहा है देखो. कर रहा. ध्यान से करना. The landing even is automated here.
रोहित क्या कर रहा था? So after completing a particular direction what we are giving, we will come back to its original position. Like we have to give. This will be called as a loiter mode. It will maintain its position within a radius of 1 meter. To the proper position. Now it's dropping on GPS, so as you can see, it's stable there. So it's just that if it gives throttle above 50%, the drone will go up, and if it gives throttle below 50%, it will automatically go down. Is that enough?
बाय बस कर.
For this receiver, we have around 2 kilometers, 1.5 centimeters.